Look up at the sky during the day. What do you see? You see a blinding sphere of plasma, the sun. It is the anchor of our existence. It dictates our days, our seasons, our climate, and our biology. From the first photosynthetic bacteria to the sprawling metropolises of human civilization, everything on Earth owes its life to the steady, reliable warmth of our local star. We take it for granted. We assume that planets and stars are a package deal, a family bound together by gravity, orbiting in a predictable, safe, cosmic clockwork. But the universe is not a safe place, and it is certainly not predictable. Imagine floating in a spacecraft, looking back at our solar system. You see the planets neatly arranged: Mercury, Venus, Earth, Mars, all the way out to Neptune. It looks peaceful, but this peace is a lie. It is the result of a violent, chaotic cosmic sorting process that happened billions of years ago. When a solar system is born from a swirling disk of gas and dust, it is a war zone. Protoplanets crash into each other. Gas giants like Jupiter migrate inward and outward, their massive gravitational fields acting like cosmic wrecking balls. In this game of planetary billiards, there are winners and there are losers. The winners settle into stable orbits. They bathe in the light of their star. They harbor oceans, atmospheres, and perhaps life. The losers are violently evicted. They are flung out of their solar systems at thousands of kilometers per second, cast out of the light, exiled into the endless freezing void of interstellar space. Astronomers call them nomad planets, orphan worlds, free-floating planets. But most commonly, they are known as rogue planets, and they are not rare. In fact, some astrophysical models suggest that for every star in our Milky Way galaxy, there could be anywhere from 2 to 100 rogue planets wandering in the dark. That means there could be trillions of them. Trillions of worlds without a sun. And today, you are going to visit one. Could you survive a rogue planet? To understand what you are about to face, we must first understand the journey. You are wearing the Aegis III Exosuit. It is a masterpiece of human engineering. It has shielded you from the crushing pressure of Jupiter and the event horizon of a black hole. But those places, as violent as they are, still belong to a system. They have a location. They have energy. Your destination today has none of those things. You leave Earth behind. You pass the orbit of Mars. You fly through the asteroid belt, past the gas giants, and finally cross the orbit of Neptune. You are now in the Kuiper Belt, the icy debris field at the edge of our solar system. Here, the sun is no longer a warming disk. It is just the brightest star in a sky full of cold points of light. But you must go further. You cross the heliopause, the boundary where the solar wind from our sun stops and the interstellar medium begins. You are now in the void between the stars. The human mind cannot comprehend the emptiness of interstellar space. If you were traveling in a commercial jet, it would take you over 4 million years just to reach the nearest star system, Alpha Centauri. In the space between here and there is virtually nothing. A few atoms of hydrogen per cubic meter. It is the ultimate desert. No landmarks, no horizon, no up, no down. Just an infinite three-dimensional abyss of blackness. Psychologically, this is where the human mind begins to break. Astronauts on the International Space Station experience the overview effect, a profound sense of connection to Earth when looking down at it. Out here, you experience the opposite, the underview effect, a crushing, overwhelming realization of your absolute insignificance. You are a microscopic speck of organic matter floating in a dead ocean. If your ship's engines failed out here, you would simply drift forever. your body perfectly preserved in the vacuum, traveling the cosmos for billions of years without ever hitting anything. But you are not here to drift. Your ship's sensors are scanning the darkness, searching for a ghost. How do you find a planet in complete darkness? It emits no light. It reflects no light. It is a black sphere against a black background. You don't look for the planet. You look for what the planet does to the light of stars far behind it. Einstein taught us that massive objects bend the fabric of space-time. As a rogue planet drifts between our telescope and a distant star, its gravity acts like a magnifying glass. It bends and magnifies the starlight for a brief moment, a few days or weeks, before returning to normal. This is called gravitational microlensing. It is how astronomers find these orphans in the dark. Your ship detects a microlensing event, a massive distortion in the star field ahead. You adjust your trajectory, you decelerate, and there it is. It doesn't appear as a world. It appears as a void, a circular patch of the sky where the stars have simply vanished, an occlusion of the background cosmos. As you get closer, your ship's active radar and LiDAR begin to paint a picture of the object. It is a terrestrial planet, roughly 3 times the mass of Earth, a super-Earth, but it looks nothing like our home. There are no swirling white clouds, no blue oceans, no green continents. It is a ball of dark, dirty, jagged ice. It is completely silent, completely still, a frozen monument to a forgotten solar system. And it is time for you to step outside. You cycle the airlock. The heavy door slides open. You step out into the void and begin your descent toward the surface. Instantly, the most brutal reality of this world hits your suit: the cold. When a planet is ejected from its solar system, it doesn't freeze instantly. It takes millions of years for a world to cool down. But eventually, the heat radiates away into space, leaving nothing behind. The temperature outside your visor is currently 3 Kelvin. That is minus 270 degrees Celsius, or minus 454 degrees Fahrenheit. This is not just cold. This is the baseline temperature of the universe itself. It is only 3 degrees above absolute zero. At absolute zero, the fundamental movement of atoms stops. Thermodynamics ceases to exist. Your Aegis suit immediately goes into critical overdrive. The internal nuclear thermal generator spins up, drawing massive amounts of power just to maintain a barrier of heat around your skin. If your suit lost power right now, you wouldn't freeze like a person in a snowstorm. The heat from your body would be aggressively sucked into the vacuum. The water in your eyes, your lungs, and your blood would simultaneously boil and freeze due to the lack of pressure and extreme cold. You would become a rigid statue of ice in a matter of seconds. As you fall closer to the surface, your altimeter shows you are passing through what should be the atmosphere. But there is no air resistance. There is no wind. Why? Because the atmosphere has collapsed. On Earth, our atmosphere is kept in a gaseous state by the heat of the sun. On this rogue planet, the temperature is so incredibly low that the gases have literally frozen and fallen to the ground. Nitrogen, oxygen, methane, carbon dioxide, they are no longer gases. They have precipitated out of the sky like a terrifying alien snowstorm millions of years ago. You are falling through a vacuum, straight toward an ocean of frozen air. Your boots make contact. There is no sound because there is no atmosphere to carry the acoustic waves. The only thing you hear is your own heavy, panicked breathing echoing inside your helmet. You turn on your suit's high-powered floodlights. The beams cut through the eternal night, illuminating the terrain for the very first time in billions of years. You are standing on a landscape of frozen nitrogen. It is harder than bedrock. Jagged, sharp formations of exotic ice stretch out as far as the beam can reach. It looks like a shattered glass cathedral covered in black dust. You begin to walk. The gravity is heavy, about 1.5 times that of Earth. Every step requires effort. The psychological weight is even heavier. You are the only source of light and warmth on an entire planetary body. You are standing on a world that has been traveling through the dark since before life even began on Earth. The isolation is absolute. If you screamed, the vibrations would only travel through the meat of your own body. You look at your wrist display. Power level, 45%. 40%, 35%. The extreme cold is draining your suit's thermal core faster than it can recharge. The Aegis suit was built for extreme environments, but it was not built to fight the ambient temperature of the cosmos indefinitely. You have maybe 20 minutes of life support left. You are going to die here. You will freeze, and your body will remain on this dark ice, perfectly preserved, drifting through the Milky Way for the rest of eternity. But then, your geological sensors pick up an anomaly, a spike in the data. You look down at your scanner. It's not reading the surface. It's penetrating deep underground, 30 kilometers below the kilometers of frozen nitrogen and water ice. The temperature is rising, minus 100 degrees, 0 degrees, plus 20 degrees Celsius. How is this possible? The planet has no sun. The answer lies in the planet's core. When a planet forms, it traps a massive amount of heat from the friction of its violent birth. Furthermore, the rocky core contains radioactive elements: uranium, thorium, potassium. Over billions of years, these elements slowly decay, releasing geothermal heat. This process doesn't require a star, it is an internal engine. On Earth, this geothermal heat drives our volcanoes and plate tectonics. On this rogue planet, the thick crust of frozen ice acts like a perfect cosmic thermos, trapping the internal heat and preventing it from escaping into space. Beneath the frozen surface, the ice melts. There is a global, pitch-black ocean of liquid water hiding beneath your feet. And where there is liquid water and a source of chemical and geothermal energy, the rules of biology dictate a terrifying yet beautiful possibility: life. Deep down, around hydrothermal vents spewing superheated minerals into the dark ocean, alien microbes could be thriving. Perhaps even complex, blind, bioluminescent creatures swimming in the warm abyss. An entire ecosystem that has never seen a sunrise. An ecosystem that doesn't even know the rest of the universe exists. They are perfectly insulated from asteroid strikes, supernovas, and the death of stars. They are the ultimate survivors of the cosmos. Your suit's alarm blares one final time. Power level critical. Life support failing. The lights on your helmet flicker and die. The darkness rushes back in, swallowing you instantly. The heating elements in your suit go cold. You feel the absolute zero of the universe creeping through the carbon nanotube weave, through your skin and into your bones. You drop to your knees on the frozen nitrogen. You came to a dead world, expecting to find a graveyard. Instead, you are standing on the roof of a hidden sanctuary, a world that was cast out of the light but refused to die. As your vision fades to black, you realize that life in the universe doesn't always need a sun. It just needs a chance. Your body freezes. You become a permanent fixture on the surface of the rogue planet, an eternal passenger on a ship sailing through the void. Could you survive a rogue planet? On the surface, you are nothing but fragile meat, but in the deep, warm, dark below, life finds a way. The universe is full of impossible places. Where should we push the limits of human survival next? Should we dive into the toxic, boiling acid clouds of Venus? Or should we attempt to land on a neutron star, the densest object in reality? Vote in the comments below. And subscribe to Could You before the light goes out forever.